Well, thank you very much for having me. After struggling through a number of very boring names, I decided to call this talk Celebrating Citizen Science, Public Participation in Science and Technology. And I really hope that this reflects a lot of the excitement and buzz that's been happening in the White House, at the science fair, and also in academia, education, and around the world as citizen science is really gaining momentum. So to start with some definitions and historical roots. The phrase citizen science entered the vernacular in 1995 from two sources within the United States of America. Rick Bonney at the Cornell Lab of Ornithology used citizen science to describe a collaboration where the public participates in scientific research, and later on others have added to meet real-world goals. And in Bonney's model of citizen science, volunteers were pretty much human sensors who were responsible for collecting data on very large scales for projects that were driven by scientific researchers. To contrast that, in the United Kingdom, Alan Irwin wrote about citizen science as a model of civic involvement, where the public understanding of science informs and shapes scientific research. In other words, this model designates public involvement in science to drive policy goals. So a few key differences. First off, who is the authority? Is it a professional scientific researcher, or is it the government and a policymaker? And this is an important consideration because it suggests different models of influence, particularly the top-down model of the United States and the more bottom-up grassroots organization of first the United Kingdom and later Europe, Africa, and other countries at large. And this is also interesting because it suggests the types of impacts. So within the United States, citizen science historically is used to advance scientific research with beneficial impacts including the education of citizen science volunteers. Whereas in Europe, citizen science was initially designated to inform policy with sort of engagement in the government as a secondary goal. So citizen science is an ancient and a time-honored tradition. Lots of people like to point to Charles Darwin as actually a quintessential citizen science volunteer, because in fact his journey on the HMS Beagle, where he collected all of the data on evolution, was conducted as a companion to the captain and not a professional researcher. And a little extra about Charles Darwin, when he came back, he actually started a massive letter writing campaign where he solicited scientific observations from his friends all over England to continue the work that he started in Galapagos. So a really good networker in addition to a scientific researcher. And formal citizen science is pretty old as well. These pictures depict volunteers working with the Audubon Christmas bird count, which started in 1900. And it's a really time-honored tradition that people participate in year after year. For example, that is my family, and I was pulled into this when I was, I think, 4 or 5, and I still do it today. It's also a changing tradition. New technologies are one of the biggest drivers of citizen science and also a driver of innovation within the field. And smartphones is sort of the entry point that lots of people point to, but I actually think that sensors are slightly more interesting. I'm not sure if anyone knows what this is, but it's actually a Microsoft Kinect. So if you or a child or a spouse own an Xbox, you have a $100 sensor on top of this device that is capable of sensing every movement to the granularity of a gesture. So if this is what you can get for $100, think about what you can get for 40 or 30, not quite so amazing, but really significant tools. And these facilitate different models of participation. So this is a typology by Mookie Hockley, which I'll reference later on, but he talks about how citizen science started as crowdsourcing, the citizens as sensors model, and then moved up through distributed intelligence, where people start to engage in data analysis, participatory science, where volunteers are also able to ask questions. And it's moving towards a really radical, extreme citizen science, where volunteers and scientists collaborate on all phases of a research project, from priority setting to building tools, collecting data, analyzing data, and even deciding how data analysis is used as advocacy later on. Now I'm just going to run through 3 exemplar projects. One of these is in the New Visions for Citizen Science book that I have copies of and I think Peter has passed around, and 2 are new. So So the first project is Galaxy Zoo. Galaxy Zoo was started in 2007 with the mission to classify over 1 million galaxies photographed in the Sloan Digital Sky Survey. And I love this project because it actually became obsolete. You can still visit the Galaxy Zoo website today. You can still click on galaxies and say that they're spiral or elliptical or whatnot, but in reality, over 1 million people have done that before you, and they have submitted 40 million classifications. So each galaxy was classified about 40 times, which is very significant for data validity. And therefore the project sort of no longer needs to exist because they've achieved their research goal. So when this happened, Galaxy Zoo recognized the power of crowdsourcing and decided to re-leverage their platform to support other types of data analysis. And since 2007, they've pulled in some more projects looking at astronomy and also some really neat things. One of my favorite projects is called Old Weather, and volunteers actually transcribe Arctic ship logs to pull out weather data that's used to study climate change. Galaxy Zoo is also a really good example of understanding your users and understanding the motivations of citizen science volunteers. So this green splotch right here is a galactic anomaly called Hanny's 4 worm. And it is so named because it was discovered by a Dutch school teacher whose name was Hanny. And she was actually the first human being to set eyes on this new type of space particle thing. So they found that discovery was a really big motivating factor. And also socialization. And when they learned this, this project implemented a discussion forum, which allowed volunteers to ask their own questions about scientific research and also just chat about things related to galaxies and not, to really build a community that propelled the project even more forward. I had to highlight a project out of the Cornell Lab of Ornithology because it really is the home for citizen science within the United States. And I picked Celebrate Urban Birds because it is unique among the Cornell projects in that its explicit goal is not necessarily to advance science, but to reach diverse urban audiences who do not already participate in science or scientific investigation. And Celebrate Urban Birds is very effective at still collecting research-grade scientific data, but scoping their data collection for different audiences, such as new citizen science volunteers. For example, participation is a very straightforward protocol. Volunteers submit species presence or absence data on 16 focal species, 10 minutes, 3 times a week. And these include things like rock pigeons and blue jays. So this is something that you can do from any urban environment, anywhere. And they're also really great with engagement. So this picture is taken from an annual competition called Funky Nests that they host. And this depicts a hummingbird nest, and I think it's New Orleans on a chandelier in somebody's front porch. And you can see sort of the party beads that are right next to the nest. And this brings in people that are motivated by art, want to get to know their communities, and really engage a lot more deeply in education and science as well. The final project is the Yukon River Intertribal Watershed Council's Indigenous Observation Network. And this project absolutely fascinates me. Their mission is to put, simply, drink water from the Yukon River. It's a network of 70 tribes. And they walk a very good line between formal and informal science and authority and data. So for example, every volunteer who participates samples water using USGS protocols that are later validated by EPA and also sent to labs in Boulder. But the project also, when they start training volunteers, goes into communities and holds workshops to identify explicit scientific and also community goals of each individual tribe and each individual community that they work with, in order to get buy-in for the project and also to make sure that they have impacts that matter for a local group. And to this, the project will publish raw data, but they refuse to publish best practices, which frustrates a lot of people since the data is so good. And the reason they do this is that a best practice differs for every different community, and they really hesitate to draw generalizations. They also use a suite of web tools like this Picasa album to integrate the less formal data and ways of knowing, such as photographs of a riverbed, with GIS mapped official data sets. So looking at some big scale trends and moving quickly, Some early accelerators sort of established, can this be done? So the National Science Foundation was actually instrumental in getting citizen science out there by including a public outreach component in a lot of their grant calls, and also through the program AZLE that funds informal science education. Early wins, such as the project Fold It, getting on the cover of Nature, also helped advance the field, and then technologies, as I discussed earlier. So now we're moving into the question of how. And to address this, the government is actually starting to make some moves through open government initiatives. Research is being conducted by leaders in the field like eBird, and also the Citizen Science Association in the United States, and also associations within Europe and within Australia are starting to collect best practices. So two specific government accelerators that I would just like to point to. 2013, the Open Government Partnership explicitly called out crowdsourcing and citizen science as open government tools to help federal agencies support their missions. And then on March 23rd, 2015, this fact sheet, which was published after the White House Science Fair, outlines a suite of new initiatives, including private-public partnerships, increased access to software, and tools through lending library programs. And there are links to these in the notes of this presentation. So I don't like the word barriers, but there are a couple sticks in the mud. And some of these are very similar to opportunities. So I'm a technologist, and giving people tools is not the same as teaching people to build tools or teaching people what to do with the data that these tools produce. And I think this is one of the big wicked problems of citizen science that no one has really solved effectively yet. Government is an accelerator and also a barrier, as I'll talk more about on the next slide. And then finally, there's this photograph of a butterfly. And this represents a talk that I saw at the Citizen Science Association conference about monitoring monarchs. And as it turns out, there are 31 citizen science programs that collect data on monarch butterflies, which is great if you're an entomologist, but there may be some duplication there. And part of the challenge of the field is to support really locally driven involvements while maintaining efficiency and sharing data across different groups. So tools to support citizen science. There are a number of inventories with different goals. This is ours. We're looking at specifically federal citizen science. SciStarter is great if you're a volunteer in search of a project to contribute data to. Citizen Science Central is from Cornell. They're evolving into the Citizen Science Association, and they're practitioner-oriented. And then citsci.org is very niche. It's just for environmental monitoring, but they're unique because they also allow projects to submit data sets, in addition to just metadata or information about the different activities. Sharing resources. I wanted to point to Citizen Science Central once again. They host white papers, a guide for evaluating learning outcomes from citizen science, which I think is probably one of the most important resources the field has, because this demonstrates impacts for volunteers and demonstrates return on investment on a number of metrics in addition to just scientific data collection. And they also have a toolkit that provides step-by-step instructions for all different parts of the citizen science process. Working within the government, this is what I do professionally. We've published a number of case studies on citizen science generally, and also specific projects, including hackathon models, citizen seismology, and more typical citizen science, and also analyses of the sort of the accelerators and the sticks in the mud. And to that later point, we are producing a report on legal, ethical, and social implications that was written by Bob Gelman, who is a very famous privacy lawyer. I'm very excited about that. And that is the bulk of my talk, but I wanted to point to a couple extra resources. I've included a very brief annotated bibliography of overarching position papers, models of participation, impacts and opportunities, motivation, and technology and games. So, thank you.